Let's quickly create a new project to go over a brief introduction to particles and pops. So we'll go over to File, New Project, and I'll select the destination. I'll just call this Intro to Pops. Hit Accept, and then I'll save the file. Intro to Pops 001. Now let's create a geometry container. And I'll call this SOP Solver Demo. Dive inside. Let's start by creating a grid. And it's just going to be a 1 square meter grid. It's fine. And on that grid, we'll scatter some points. Let's say 100 points. And we'll disable the relaxed iterations. Let me disable the grid and also switch to a dark background. So clicking D, background, dark. So these are the particles or the points that we generated on the surface. A particle solver will do is essentially grab the point's position and each point's velocity and calculate what the next point's position will be based on that velocity. Position is just a vector, so you have 3 floats for each one of these coordinates, x, y, and z. A velocity is also going to be a vector, which with 3 floats for each one of the coordinates. And that vector is going to give us the direction of the movement and also the speed. The length of that vector is also going to give us the speed of the object, in this case the points. So what we'll do is we'll just create an attribute. I'm going to go to attribute create, and we'll create an attribute called v from velocity. It's going to be a type vector. And we'll say that the value is going to be, let's say, 1. So the velocity right now, it's going to be the units, as you know, inside Houdini is in meters, the spatial units. The velocity is going to be in meters per second. So right now what I'm saying that will be these points have a velocity of 1 meter per second on the y-axis. Nothing has happened. But if we were to do the calculation ourselves, we would, for instance, create a point wrangle and do a very simple line of code where we say that my position at P is going to be equal to my position plus my velocity, semicolon. And we have some displacement happening. So this is before we calculate the new position. I'm going to call this create val, create v. And here I'm going to call update position. So we updated the position. As soon as this information comes in, this line of code is applied to the points and we get a new position. But if you move the time slider, this doesn't continue to happen. Okay, we would need to apply this again, and those would keep moving, and so on and so forth. And they would keep moving. Now, of course, we don't do this like that. There is a solver, a SOP solver in Houdini, so you can just type solver, that will be able to apply whatever operations you want to apply to your geometry through time, meaning that it will take into account the previous frame to apply that operation on the previous frame, and so on and so forth, going forward through time. So the difference will be that if we connect this here and we copy this update position, Control C, inside the solver. You'll see that inside the solver we have input 1, input 2, input 3, input 4, which will correspond to these inputs. And we have the previous frame. If we Control V the update position here, and we feed it the previous frame, what this means is that on each frame, the solver is going to look at the previous frame and apply this wrangle, this update position operation. If we go up now and we look at the solver, what we'll see is that the particles keep moving, continue to move through time. And you'll also notice that the timeline, let me just adjust this, we don't need as many, let's say 120. So I'm just adjusting the length of our timeline. You'll notice that our timeline starts getting blue, which means that this is being cached. You also have a reset simulation here, which indicates that this is being simulated through time. Okay. Now, this isn't correct because we know that our timeline is in frames and our file is working at 24 frames per second. So if we have a look at this from a front view, spacebar 3, and we turn on the grid. So if this is 1 unit, or if this is 1 unit, okay, 1, 2, what we would expect is after 1 second, knowing that the velocity is in meters per second, after 1 second, meaning 24 frames, our particles should be at this position. But that's not what's happening. Okay? On each frame, it's jumping 1 meter. And the reason for that is because we're applying on this update position, we're not applying it correctly. We're not taking into consideration that the solver is going to be running through per frame and not per second. So even though the speed is per second, the solver is going to be applied per frame. So we need to take that into account, and it's pretty easy to do. All we need to do is multiply our velocity by the time increment, which is also a global variable that we have inside Houdini. And it's written like this. The order of operations here is going to be first you have the multiplication happening, and then you will have the addition happening. Okay. Now this time increment will be updated according to your frames per second, and it'll know that in this case it's going to be 1 by 24. Okay, and we're going to be applying a 24th of the velocity on each frame, meaning that right now if we go up, so now the particles will only reach the height of 2 at frame 24. Let me go spacebar 3, and that's what we should have. Okay, we start at 0, we start at 0, and then they go up, and at frame 24 they're at this height. At frame 48 they'll be at that height. Okay, now it's correct. This is one of the common operations that the pop solver will do. Let me just turn on here the real time. And this is the speed of our particles.